So today we're going to go over transformations, and transformations are simply just things that we do to graphs to make them look different from each other. And our goals for today are to be able to understand what a transformation is and be able to use and apply that understanding to use these transformations to graph parabolas. Basically, they become our cheat sheet in a way so that we can graph something without actually having to go through all of the steps and plugging in all the points. We're going to go over the parent function really quickly. A parent function just in general is the function that is like the perfect function or the perfect example of a certain graph. And every parabola that we're talking about is a result of a transformation from a parent function. And this parent function is f of x is equal to x squared. It's the same thing as the parent function f of x is equal to x. That's the perfect line. And this is our perfect parabola. We can transform, which means to move around, scale, which means to stretch or to squish, and reflect or flip our graphs around to get a different type of graph. Now we're going to go over transformations really quick, and here we have a transformer to remind us of this. And we're given the equation, and we're given it in vertex form, which is f of x is equal to a times the quantity x minus h squared plus k. And a transformation moves the vertex and the rest of the graph to a new spot. So remember, vertex form gives us the vertex within it. If we transform it, we're going to move it around according to that. So h changes the location of the x, and you notice that inside of our vertex form, it's naturally minus. So it's going to be inverted. Our change in x is inverted of what it says in here. So if it says minus h, instead of going in the negative direction, we're actually going to go in the positive direction by that number. And we have k as well, and k changes the location of the vertex and its y coordinate, and that's just going to happen like normal. So we're going to graph our parent function here, which is f of x is equal to x squared. There's no real secret to this one. You just have to, like, 0 squared is 0, 1 squared is 1, 2 squared is 4. And you can graph it, and you get a pretty nice parabola, and this is our basic parabola that we're going to be working with. And there it magically transforms for us. So now we're going to graph these two parabolas in our blue and our green. And remember our vertex form, which is f of x is equal to a times x minus h plus k. And these two both have h's. So since they both have h's, what we're going to do is we're going to change it. We're going to either move it to the left or to the right according to that value inside of it. So our first one is f of x is equal to x minus 1 squared. And so since we have a negative 1 in here, the negative matches with our negative in here, so it's actually going to be a positive. So we're only going to go over 1. That means that our vertex has been shifted to the right, or in other words, a positive x direction by 1. And then every other number is going to be the same. And I'm going to leave you to confirm this if you want to, but if you plug in these basic numbers, you'll find out that it's exactly the same. It's just shifted over by 1. And I'm doing my best that I can to replicate it, but you notice that the parabola looks almost exactly the same. Here, let's get that a little bit better. So that our parabola is looking as close to the same as we can, and it's just been moved to the right one. And now if we look at this one here, it's a plus 1. Since it's a plus 1, it's the opposite, and so we're going to have to say that that's actually minus a negative h, or in other words, plus h. So since we're minusing a negative that we're subtracting is actually a 1, so we're going to go to the right, to the left 1. And our vertex just moved over. Our points are going to be the same points, just moved over by 1. And then we go ahead and graph it like so. And besides the fact that it looks really trippy, which I really like this, we just noticed that the green one, which is a plus 1, was just shifted to the left, or in other words, the negative x direction by 1. The blue one was shifted to the right, a positive 1 in the x direction. Now, if we're going to play with them again, remember our vertex form is f of x is equal to a times x minus h plus k. In both of these, you're going to notice that they're both minus 1, so we know that they're both, since they're negative, that means that they're actually being shifted to the right. Remember that I'm dyslexic, so I have to remember what direction is right. So to the right 1, or positive x direction by 1. And it's basically because if you're to try and set this chunk equal to 0, you now have a little bit of wiggle room. You actually have 1 of wiggle room to be able to play with. So everything is just going to add an extra 1 as you're playing. And our only difference here between these two is one is a plus 1 and one is a minus 1 for our k. And so since this one isn't inverted, this one's normal, what we're going to do is when it's for blue, since it's plus 1, we're just going to move up 1. And then everything else is going to be shifted up by 1. So it's over 1. So it'd be the same exact thing as if it was, so it's been moved over by 1 and up by 1, and it looks exactly the same as if it was at the origin. Now we're going to do it with our green one. And our green one, instead of being a plus 1, it's minus 1. So instead of going up to 1, we're going to go down to negative 1. And then everything is the same. There and there. And you'll notice that it's a little bit hard to see on this one. But all you're doing is you've just moved this vertex, so we have a vertex here. In our blue one, it's been pushed over 1, up 1. In our green, it's been pushed down 1, over 1, down 1. And now if we wanted to, we could go ahead and play with this one. I'm just going to do it really quickly. So we have a minus 3, which means that we're going up. That means that we're going to the right 3. Plus 2, we goes up here. And then we can, then we can go 1, 2, 3, and there's our graph. And if you want to, you can go ahead and throw it into your graphing calculator and check it. So for this quick check, what I want you to do is describe the transformation. For example, if we're to go back to here, we could say that it's right 3, up 2. So on these ones, we're going to describe the transformations in words. Go ahead and pause the video and do this quick check.